Welcome to today's video production of arithmetic sequences brought to you by your fabulous Barnegat High School math department. First thing you need to know is that the word arithmetic is actually pronounced that way. I know it looks like arithmetic, but we are the math department, and actually I looked it up on YouTube and it is arithmetic. So first thing you got to do here is write down the definition. If at any time the video goes too fast, just pause and then fill out your stuff and start again. The word sequence and terms are in red because they're defined later on the definition page. And our definition here is an arithmetic sequence is a sequence where the difference between consecutive terms is the same. Consecutive meaning one after another. The most important word in this definition is difference, because in math the word difference means subtract, and that's what we're going to do. We're going to subtract the first term from the second term, which will get us a difference, and if all the difference is the same, it'll be a sequence, and that's how we'll know. So second term minus the first term, 8 minus 3 gives us positive 5, so we'll write that down here. And then we have to check the third term minus the second term and the fourth term minus the third term. And if all the differences are plus 5, which they are, like 13 minus 8 is 5, if all the differences are the same, they're a common difference of plus 5, and that means this is an arithmetic sequence. So let's check our second example. We take negative 1.7, our second term, and we subtract negative 0.7, and minus a negative is a positive, so we've got negative 1.7 plus 0.7, and that equals negative 1. And we'll write that here, negative 1. Then we have to check our third term minus our second term, and negative 2.7 minus negative 1.7 is also negative 1. They are all negative 1. Common difference is negative 1, and we have a second arithmetic sequence. We'll check our third example. 2.2 minus 1.6 is 0.6. And one way to look at it is that it went up plus 0.6. And if they all go up plus 0.6, which they do, plus 0.6, plus 0.6, plus 0.6, plus 0.6, if they all go up the same amount, it is a common difference of plus 0.6. And yes, we have yet again an arithmetic sequence. But this is math, and you know we're going to show you one that doesn't work so you can see the difference. And if you look at example 4, 2 minus 1 is positive 1. But if we subtract the second term from the third term, we've got 4 minus 2, which is different, so it's not a common difference. And this thing is a no, not an arithmetic sequence. So that's how you tell if a term is an arithmetic sequence. And we'll now fill out the vocabulary page. The word sequence means an ordered list of numbers. For example, 33, 29, 25, 21, 17, and 13 is a sequence. You'll have to write in 17 and 13, and you probably already know why, but we'll go through the motions. A term is what you call each number in a sequence. And for example, in the sequence above, 17 is the 1, 2, 3, 4, 5, fifth term. Last vocabulary word is common difference, which we call D. When the difference between each term in a sequence is the same, it's called the common difference. And you don't have to write this down again because it's already up here, but 29 minus 33 is negative 4, and they're all the same, and that's how we got 17, because if our difference is negative 4, 21 minus 4 is 17, and 17 minus 4 is 13, and that's our sequence. Remember, an arithmetic sequence is an ordered list of numbers with a common difference. They go up or they go down. The common difference could be positive or negative, but it is always the same number. So, the third thing you need to do is graph an arithmetic sequence. We're going to use example 1, which was those numbers there, and it's really straightforward. I like the word arithmetic. Every single term has a position: first position, second position, third position. So it's 1, 2, 3, 4, 5, 6. And if there's a dot, 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 because we could keep adding 5 for a long time. Frankly, we could do it forever. So if we did it for a while and we got to some number that we didn't know what it was, dot, 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 like it's so far out, we just stopped counting, kept going, plus 5. We got some number, we're going to call it n, the nth number. Now back to the chart. Every position has a name. They call it the A. Every single thing is in an A position, but the first one is A sub 1. Sub because it's a little subscript. So 3 is called A sub 1. It's in first position. And 8 is called A sub 2. And 13 is called A sub 3. Whatever number is third is the A sub 3 number. And A sub 4, 5, A sub 6. And we call the nth number is in A sub n. And what term goes in A sub 1? Well, 3 term 8 goes in A sub 2, 13 goes in A sub 3, etc. What number goes in A sub n? Well, we don't actually know because we don't know what n is, but there is a formula we can use to figure it out. And you will have to memorize this formula, and it is this. A sub n equals A sub 1 plus d times the quantity of n minus 1. And you should write that down. Now back to graphing. We're going to make a t-table because that's the easiest way to graph, and all the x's are the positions 1 through 6. And all the y's are the terms 3, 8, 13, 18, 23, and 28. So you fill those out, and you'll notice we got us an xy ordered pair, so we can graph. And the graph is not symmetrical. I got it off Desmos. It's 1, 2, 3, 4, 5 there, and these go up in 2s, 2, 4, 6, 8, 10. So if we were going to graph our first ordered pair 1, 3, we'd go over 1 and up 3, so that'd be 2, that'd be 3 right there. And there's our first point. Second point would be at 2, 8. Third point would be at 3, 13. Fourth point would be at 4, 18. Fifth point would be at 5, 23. And I couldn't fit 625, but it's up here somewhere. And what you need to know is that this is a straight line because our change in x, delta x, is 1 every single time, and our change in y is 5 every single time. Sorry about that. Is 5 every single time. So we've got a constant rate of change when we've got a straight line slope with 5 over 1. So m equals 5. And that's how you graph an arithmetic sequence. So back to that equation that I really didn't give you enough time to write down before, and you should try to memorize it now so you don't have to do it later. It's a sub n, etc. A sub n is your nth term, the one we're looking for. We don't know what it is yet. And a sub 1 is your first term. In our last sequence it was 3, but whatever sequence you got, it's just the first term. D is the common difference. In the example we were working with, D was 5, but it could be whatever it is. And n is the answer, the number that you want, the nth term. For example, if I want the 10th term, well, I would write 10 everywhere I see the letter n. So I would say a sub 10 equals a sub 1 plus d times n. I would actually put a 10 in there. And I would just figure it out. You can't do anything yet because we don't know what the common difference is. We just know it's d. They'd actually have to give you a number for that. And we need to know what the first term was, which they didn't actually tell us that yet. But coming up is an example. Wait, quick quiz update. I will probably give you a quiz, simply give you a blank piece of paper with some bars on it and ask you what these are. I may ask you to fill out what that is. See if you can do it now. And if you can't, don't worry, you will be able to. And you can look it up. Actually, I'll even tell you, there it is. A sub n equals a sub 1 plus d times n minus 1. This is the term you're going to look for. This is your first term. This is your common difference. And n is the number you're looking for. We'll get there. So, and you can relax. This is absolutely the last page. If you want the 10th term, you're going to get a problem that says something like this. Find the 10th term of a sequence with a sub 1 equals 17 and a common difference of d equals 7. So there's steps. For people that like steps, first thing you got to do is write down this formula that you've memorized by now. And the second thing you do is just plug in the blanks. So we know that everywhere you see the letter n, you're going to write 10. So the a sub 10th term, and we'll write a 10 there. And a sub 1 equals 17, so we put a 17 for a sub 1, and the common difference d equals 7, we'll put the 7 in. And then all you have to do is solve. And we use PEMDAS, so we know that 10 minus 1 is 9. And then we're going to multiply the 7 times the 9, get 63. And then we're going to add the 17 and the 63, and we're going to get 80. So the 10th term in this sequence that started at 17 and went plus 7 every time was 80. And if you wanted to check that, that is our answer. If you wanted to check that, you could actually write it out. Although on a test, I will probably give you one that it would be too much trouble to write out just because I really care that you know the formula. But we start off with 17, that's our first term, and we add 7 each time. So 24, 31, 38, 45. Keep adding 7 every single time. And by the time we got to the 10th term, it would indeed be 80 because it works. And that's it. Have a nice day.